Hello everyone. In this lecture, we will begin our journey into object-oriented programming. Unlike procedural programming, this object-oriented programming organizes programs around objects, making software modular, reusable, and easier to maintain. Today, we will understand the principles and characteristics that makes this object-oriented programming one of the most popular programming paradigms. Starting on with what is object oriented programming. It is programming methodology that models real world entities as objects. An object combines data called as attribute functions called methods into a single unit. This approach improves code organization and simplifies the software development. Why we need object oriented programming? As software application becomes larger and more complex, procedural programming becomes difficult to manage. So object oriented programming solves these problems by promoting code reusability, modularity, security, and easy maintenance options. So this is why most modern software is developed using object oriented principles. So here is the real life analogy, the four pillars. So you may think car. Every car has properties such as color, model, speed, along with behaviors like starting, accelerating, and braking. In object-oriented programming, car is the object. Its properties becomes the data members, and its behaviors becomes the member functions. To start on with the basic concepts, class and object. So class is blueprint used to create objects, while an object is the actual instance of that class. For example, student can be a class. Priya, Rahul, Akshay are individual objects created for that particular class. So here defining a class. So class is a blueprint. It declares the data members and member functions an object will have. So nothing is created in memory. The classes only describes the shape of the future objects. Here, car is the class. Next comes creating objects. So this example displays how objects are created. Here, my car is an object of the class called car. Next, it's important to know about the access specifiers. We are discussing about three different specifiers here. One is public, private, and protected. So in public, it is accessible from anywhere. The object is visible actually when it is public. When the access specifier is private, it's reachable only inside the particular class, and this is only default. And protected is like private, but only visible to derived classes. Next comes encapsulation. So encapsulations means binding data and functions together inside a class while protecting the data from direct access. Private data can only be accessed through public member functions, ensuring better security and integrity. And safety, control, and flexibility are the important aspects in encapsulation. Here is an example of the bank account. The account balance is the private. The user cannot modify it directly. Instead, use methods such as deposit and withdraw, which validates every transaction before updating the balance. Here are getter setter exam methods examples. So benefits of encapsulation, or it protects the data from unauthorized access, reduce errors, and improves maintainability, and allows the internal implementation of a class to change without affecting the rest of the program. That is encapsulation. Next comes abstraction. Abstraction means showing only the essential features while hiding implementation details. Users actually interact with an object through a simple interface without worrying about its internal working. Here is an example. Next comes the inheritance. So inheritance allows one class to acquire the properties of and functions of the another class. The existing class is called the base class and the new class is known as the derived class. Inheritance concepts promotes code reusability. The various types of inheritance are single inheritance, multi-level inheritance, multiple inheritance, hierarchical inheritance, and hybrid inheritance. Each type provides different ways of sharing functionality among classes. First, starting with single inheritance, the class is animal, and this is an example of single inheritance. And here it is multi-level inheritance. Animal is a class, dog inherits animal, and puppy inherits dog. So it is example for multi-level inheritance. Next comes the polymorphism. Polymorphism means one interface, many forms. The same function or operator behaves differently depending on the context, making programs more flexible. The various types of polymorphisms, compile time polymorphism is achieved through functions and operator overloading, while runtime polymorphism is achieved using virtual functions. Next comes function overloading. Function overloading allows multiple functions to have the same name but different parameter lists. The compiler automatically selects the correct functions based on the arguments. Next is we have to know about the runtime polymorphism. So in runtime polymorphism, a base class pointer can refer to different derived class objects. Dynamic binding is a concept here that delays the sections of functions until runtime, and various advantages of object oriented programming are mainly it offers several advantages including modularity, code reuse, improved security, and easier debugging and simpler maintenance and better scalability for larger applications. Next comes the constructors and destructors. So here is the constructor. The constructor shares the class name and runs the moment an object is created. And destructor is specified by the tilde sign. So it is denoted here. It runs automatically when the object leaves scopes. It is destructor is ideal for cleanup options. Whenever cleanup is required, destructors can be called. So far, we have learnt about encapsulation, abstraction, inheritance, and polymorphism. So also we have learnt about the characteristics of object-oriented programming, foundations in modern C++ application development. So these are very basic fundamental concepts for object-oriented programming. See you in the next session. Thank you.